everyone. So let's try to solve one more problem from TIFR 2024, and it's a very simple question, straightforward but very conceptual. So what is that? It is given that for a harmonic oscillator, the one particular wave function is given. And you can see there is some algebraic part and another is Gaussian part. So we have the algebraic part, and that algebraic part is the Hermite polynomial, and Gaussian part is due to just square integrability. So you have to just understand all these things. So what is that? What is question? So one wave function is given. So what we have to do? We have to find the another wave function which is closest to this particular energy. That means if it has some particular level, and if you will see that here the maximum power is 3, so that will be n is equal to 3. So what will be the closest wave function for the n is equal to 4 and n is equal to 2? That is the closest one. So you have to be very much careful, and there is no need to remember the Hermite polynomials and all these things. Very simple. What you have, this wave function is antisymmetric. So next higher level and next lower level will have always symmetric wave function. This is the one of the most important concept. And second thing is that it has highest power is 3. So next higher level have power 4 and the lower level have power 2. But these two have symmetric wave function. We have to always take care. And you can see they have given in a very nicely notation that psi a, that means it is antisymmetric. So if you will see the all wave function of the harmonic oscillator, then ground state is symmetric, first excited state is antisymmetric, and after then symmetric and antisymmetric you can have, because this harmonic oscillator is symmetric about x is equal to 0 and parity is going to conserve. So there is not any need to solve this one. You have to just see. So first option you can see that this is symmetric wave function. This is also symmetric wave function. So yes, this will be just lower to this one and this will be just higher to this one. Another you can see this is symmetric, but thing is that this will be not the next lower, this will be the ground state. So this is not option even if they are following the symmetry. And if you will go, these two are antisymmetric, so these are not possible. And this is symmetric, this is antisymmetric, so these two are also not possible. So students, in this particular questions, you need not to solve anything, you need not to remember anything, but what you have to do, you have to understand the symmetry of a system. So option number A is correct. Thank you.